Okay, so today's job, we're on a Komatsu digger here, and what we've been asked to do is to install a traditional CB radio on this digger. Traditional CB radio in New Zealand is 26 megs AM, and we've also been asked to install a PRS radio. Now, PRS is described by the Australians as UHF-CB, but we're going to call it PRS here because that's its proper term in New Zealand. Now, PRS is 477 megs, and it's FM. Now, this Komatsu's actually got a bracket. Somebody's conveniently provided a bracket for us. And I suspect that this antenna here is actually used for AM/FM. This antenna is some sort of location thing inside a Komatsu digger, and there's a remaining position here. Now we've had a discussion about whether or not we use this location. Bearing in mind here, this bracket, there is a ground plane on this side, but over this side we've got fresh air. So we don't have a complete ground plane here. So if we put an aerial here, we should really be putting a ground independent antenna. And we bought a couple of ground independent antennas along. This is a PRS ground independent antenna. So it's a part number's AE412K for kilo, AE412K1. It's an elevated feed antenna. And so this part of the antenna is actually radiating, and so is the top portion. So that's a ground independent antenna for 477 megs, and we actually have a ground independent antenna for traditional CB as well. So this antenna is an AE220N. We could fit either of those out here on this bracket where we have no ground plane. The problem that we've got is when this radio transmits, because there's only about 3 inches between there and there, we're very likely to get a significant amount of energy being transferred from whichever aerial we put on here into our AM/FM radio. So we've elected not to use this at all. We've elected indeed to use the ground plane provided by the cab roof, or this rollover protection system, which is provided on the digger. So we'll just put these ground independent aerials up here, and we'll talk about ground plane aerials. So a ground plane aerial, or an aerial which is not ground independent, is probably the best way to describe it. An aerial which is not ground independent requires a ground plane, and it requires a ground plane to provide a radio reflective surface for the antenna to work correctly and radiate correctly. Now, generically, as a rough rule of thumb, the size of this ground plane, or this counterpoise is its proper name, or radio reflective surface, is roughly, you use the antenna here to determine the radius of the circle. So we've actually got plenty of space here. So we're going to put a quarter wave whip at 27 megs. That's an AE2400N antenna there. And we're going to put a AE4012 antenna over here. Now this is a PRS antenna. It's actually a gain antenna. The coil in the middle, by the way, is a phasing coil. What it's designed to do, it still needs a ground plane. This antenna still needs a ground plane for it to work correctly. The size of the ground plane you can determine by, a rough rule of thumb, the size of the antenna. The phasing coil and the top loading alters the radiation pattern of the antenna so that the radiation is more sideways and less of the RF is actually radiated at high angles up into the air, because we don't have too many customers at high angles. Up there we've got aeroplanes and helicopters, and that's about it. So that's what we're going to do today, and that's the sort of the logic and the reasoning here. Okay, so we're on our digger, and we've started the camera again. We've finished our installation. Here's the bracket on the side that we didn't use. No ground plane here. Fresh air. Can't get counterpoise or ground plane from fresh air. We've got a ground plane on that side, so we elected not to use this bracket. Right over here, we have two ground plane aerials. You can actually see, there's the aerial, I'll point it with my finger. There's the antenna. And because we've got a nice shiny roof, you can actually see the reflection. There it is there. So we've got a quarter wave up here, and we've got a quarter wave in image down there. So this aerial will work correctly. You need to bear in mind that when you're using counterpoises, that there's quite a high current flow at this end. So here, you've got high current here and high voltage at the tip of the aerial. Now the other antenna over here, we've got a similar situation. There's the antenna. Now this top piece is, of course, is the phasing coil to prevent radiation leaving the antenna at high angles. This lower portion here is effectively the quarter wave. And if we look really carefully, there's the image of it. There's the image of the quarter wave, there's the image of the phasing coil, and then the upper portion there. So we've actually got a correctly installed center fed quarter wave. The image is down underneath there. So both these aerials will work correctly. And there's an adequate ground plane around that antenna there because it's in from the edge. And we've got an adequate ground plane around this one as well because it's in from the edge. Okay. And we've not used this at all. We've got adequate separation between our aerials, with adequate separation between our UHF aerial, our PRS aerial, and our traditional CB aerial at 26 megs, and this thing which we believe is actually the AM/FM aerial.